Well, thank you, Kermit, and good afternoon. I'm very pleased to be able to speak with you today about a subject that is becoming more and more important: reliability. I've been around long enough to remember three distinct phases on how we operated our generation facilities. Back in the 80s and 90s and even into the early 2000s, it was all about efficiency. Almost every plant we operated was running at full load at the time, so we went out of our way to squeeze every bit of generation that we could out of each BTU of fuel input. We maximized efficiency. In the late 2000s and 2010s, with the growth of renewable generation, the onset of natural gas-fired peaking plants, and most importantly, the development of regional transmission organizations like SPP and MISO, the key word for plant operations was viability. How do we cut costs? How do we make our facilities more flexible? How do we balance complex parameters such as ramp rates, ancillary services, and minimum loads to ensure that our units were called into the market at the right price? We maximized viability. Fast forward to today, and it's all about reliability. And it's not just me talking about it. It's not just the people who have joined me on the stage that are talking about it. In fact, it's not just even Basin Electric talking about it. With the exponential increase in intermittent generation, coupled with the closure of gigawatt after gigawatt of dispatchable generation, and finally the rapid electric load growth across all facets of life, more and more you hear concerns about reliability. Whether it's the national news, or regional transmission organizations, or electric reliability councils, or even politicians, the concern is the same. And the concern is valid. We now need to maximize reliability. We haven't forgotten about efficiency or viability, mind you. As we stand here today, reliability is king. Joining me today are 5 individuals who are ultimately responsible for reliability at both Basin Electric and Dakota Gas. We will dig a little bit deeper into how each of them see reliability and how they and their teams are working hard to keep our facilities online. But first, I want to tell you a little story about the recent outage at the Laramie River Station. Levi Mickelson, the LRS plant manager, later called it the outage from heck. The outage was being extended due to a problem with the boiler feed pump, which had been sent away for rework. Upon its return, the plant personnel noticed problems with the fit-up and the tolerances of that pump, which made it unusable. The outage would need to be extended a few more weeks to make those repairs. At first, there was a thought that we could put an old pump in its place, one of the same model that had been removed at the beginning of the outage. This pump did have some issues, but it could just sit there in place and we could run the plant in a derated condition. As critical as energy was at the time, we thought it might be a decent alternative to being offline altogether. The concerns were that it would take quite a bit of time to get the old pump welded back in, then it'd run for a little bit, then it'd take quite a bit of time to get it back out and the new one back in. So we decided against that. Another option we thought was to start the plant up with no pump in place, just close the return and supply valves. Then we thought a little bit more about the risks. We weren't 100% sure that if the boiler was put up to full load, that those valves would hold. Or if there happened to be a full load trip, that the pipe hangers and the pipe supports would maintain their integrity. In either of these cases, there was a possibility of a leak. And with that, high pressure boiler feed water would instantly flash into steam, potentially causing life-threatening situations for anyone in the area. The decision was made to play it safe, extend the outage, and wait to start up until later. I tell you this story to make sure you understand that as important as reliability is, we will never sacrifice safety to obtain it. Now let's transition to our reliability panel discussion. Today I'm joined by 5 individuals who represent over 1,500 men and women who work hard every day to keep your generation, transmission, and the subsidiary facilities as reliable as humanly possible. Aaron Ducart, Director of Environmental Services. Aaron's division is responsible for permitting all new facilities and environmental compliance at existing facilities. She has been at Basin Electric for almost 16 years and has a biology degree from the University of North Dakota. When not working, Erin enjoys chasing her kids and chauffeuring them to their various activities. Troy Tweeton, Senior Vice President of Generation. Troy is responsible for all the Basin Electric generation facilities, as well as Dakota Coal and Montana Limestone. He's been with Basin for a little more than 15 years and worked in the power industry for about 39 years. Troy has an Associate's of Applied Science at Bismarck State College in Power Plant Technology. In his spare time, he enjoys hunting and going to the Rocky Mountains. Trinity Turnbow, Vice President and Operations Manager at Dakota Gas. Trinity leads DGC's operations, the chemical lab, and protection services. He's been with DGC for 16 years and worked in the chemical industry for 22 years. He has a chemical engineering degree from the University of Minnesota Twin Cities. And Trinity is addicted to escape rooms. And as of today, he has escaped 43 of the 44 rooms he has visited. And that's what I call reliable. Val Weigel, Vice President of Energy Markets. Her team manages Basin and DGC's power, natural gas, fertilizer, and other commodity exposures. She has been with Basin Electric for 24 years and has a business degree from the University of Mary and an MBA from the University of North Dakota. Val enjoys spending time in the sun, reading books, and getting her nails done more often than she can reasonably justify. Finally, Jeremy Severson, Vice President of Transmission. Jeremy oversees transmission services, transmission rates, and transmission system maintenance. He has been with Basin Electric for 21 years and has an electrical engineering degree from the North Dakota State University. Go Bison. An interesting thing about Jeremy is during family trips or business trips or any trips for that matter, Jeremy likes to take pictures of transmission lines and substations. So go figure. Can we give our panelists a round of applause while I join them for the discussion? Well, first of all, I want to thank all of you for being here. It's my privilege to get to work with you every day, and I'm really excited about the opportunity to share your expertise and your desire for reliability with the folks that are in the room. So Troy, let's start with you. One of our cooperative goals this year, and last year for that matter, was reliability. So can you tell us about that goal specifically related to the generation facilities and tell us how we're doing in meeting it?
Sure. So the reliability goal is a three-part goal that includes our high voltage transmission line, our natural gas fleet, and our coal fleet. We use the average equivalent unplanned outage factor as a measuring metric for that. And in that, I guess just to break that down a little bit more, the term equivalent, that would include all our derate and outage hours that are associated with a unplanned forced outage. And the unplanned forced outage hours are any hours that, or outages that are not in our 10-year tentative maintenance outage schedule. And then it would also be outages that we can't get scheduled and be into the market, you know, where we let them know, hey, we'll be out of the market. So that's usually with 48 hours notice or not making it through to a weekend. The other thing with the factor on that, we used to do a rate and we changed it to the EUOF using the factor because that includes all hours throughout the 1 year time period, and the rate would just have the percentage for those hours that we would compare that back to. So it was hard to go back and do a year-over-year comparison because the percentage of hours the unit was available wasn't always the same. So we changed it to the, excuse me, EUOF. So with that, the natural gas fleet has to perform 2% better than they did last year. The coal fleet is broke down into kind of two parts. First, they have to perform better than they did last year. And then next, they have to do 2% less than the NERC Generating Statistic Brochure 1 average for coal fleets. The NERC Generating Statistic Brochure, that has public data for all NERC facilities in the United States, excuse me, in the United States, Canada, and part of Mexico. Right now, the gas fleet is currently not making that goal year to date. If you're optimistic, we do have a chance that we could try to make that goal, but we would have to run without any forced outages for the rest of the year. But realistically, that probably won't happen.
And how are we doing on the coal?
Coal fleet, yeah, I'm sorry, coal fleet is on target to make it this year. So.
Okay. Well, that's very good about the coal units, and I know that takes a lot of work from you and all your team to make that happen. But I need to ask, what's some of the issues that we're seeing with the gas fleet, and why aren't we making that goal?
Yeah, so the gas fleet, we run very hard with high capacity factors. Pretty much run some of our units as base load units in some of our service territory. And running this way, we hit some of our service maintenance hours faster than originally projected. And then even with some of our units like Culbertson Gas Station and Groton Gas Station, we have parts and major components that are failing a lot faster than their anticipated end of life. But that's causing some issues. We still have supply chain issues that are causing long lead time to get parts. We also have issues with repair shops and getting the components in there for the repairs. These long lead times, part delays, and shop delays, that all ties in. It's with all manufacturers, so it's not nearly just one manufacturer that's having an issue with it. It's worldwide. It's kind of been that way ever since COVID. Still trying to work through that, getting workforces back. But these long lead times and shop delays, unfortunately, have a big impact on our gas fleet reliability.
Okay, thanks, Troy. But given some of those issues with timing, getting equipment returned after it's been repaired and whatnot, have we done anything special or significant to offset that and make sure we have backup equipment when we need it?
Yeah, we've been ordering extra parts, trying to build up our inventory in the warehouses. We've also been working with some of the other cooperatives, trying to share some parts, but that can kind of be a catch-22, because if you have a unit that has some issues and then next thing you have a failure, now you need those parts, but everybody does a risk analysis and we share what we can. Another thing that we've done is we've ordered 2 combustion turbines, some LM6000 units for our Lonesome Creek Station and our Pioneer Station. So these are full combustion turbine units that once they arrive and we have a failure, we'll be able to swap those out, put one back in place, still be able to generate some power while the other one's being shipped off for repairs.
Okay, thanks, Troy. Switch over to Jeremy for a minute. Troy did a pretty good job of explaining the EUOF factor, which I affectionately call the UFTA factor. Is there a similar measurement used in the transmission system, and are we meeting our goal there?
Yeah, we have a similar measure. We're not as good as spellers, so we just went with a forced outage rate, and we get that forced outage rate, or 4, out of the NERC State of Reliability Report. And that number that we get out of that report is 0.25, kind of the industry standard, and our goal is to be better than that 0.25. And so I'm happy to say that year to date, the transmission FOR is 0.06, which is equating to our transmission being available more than 99.94% of the time. So very highly reliable, available, and we equate availability to reliability. We've had some good things this year. We've had some good weather, knock on wood. But we've also tried to reduce human error, you get things back up in service, and also stick to a healthy maintenance schedule. So doing our maintenance whether it's on a monthly, yearly, sometimes up to 5-10 years on unscheduled maintenance.
Thanks. Can you tell me a little bit more about those planned maintenance activities and why are they so important?
Yeah, those planned maintenance events that we do at the various substations help us kind of baseline equipment and facilities, helps look for degradation over time. We had one of these planned maintenance events. Of course, we have them yearly, but the spring down at the Sydney 345 230 kV station, transmission system maintenance crews were doing their annual checks on the Sydney 345 230 transformer, and took some oil samples and compared that to some previous samples and found some high gassing that was occurring in that transformer. And that's was occurring probably due to some internal arcing of the transformer. And so we were able to safely remove that transformer. It's about a 44-year-old transformer. Remove that from service and get away from a critical event that could have catastrophic failure of the transformer. In addition to that, about 10 years ago, staff at Basin and MBPP made the decision to purchase a spare transformer, which was placed at the Laramie River Station. And so over the course of the past few months, staff has been working to remove the old transformer and get the spare transformer from LRS over into that location. So having the ability to move in a large transformer in about 3 to 4 months versus kind of a 5-year lead time on those transformers is a good notion, or good kudos to staff to get that in service in a quick time frame.
Well, that's a good story, Jeremy. It shows a lot of foresight from your staff and the teams for ordering that spare one back in 2012, and even more good work to catch this new one before there's something catastrophic. I know it takes more than your team to get all that done. I know it takes a lot of different departments, but my hat is off to you and yours for organizing all that. So speaking of planned maintenance intervals, stuff like that, Trinity, I remember you telling us about an important event coming up last year during this panel at the DGC, something called a black plant outage. What is that and what's it for?
Yeah, Gavin, a black plant outage is something at DGC where everything is down. So typically we take one train down while the other train is online during an outage. Black plant is where both trains are down, including common equipment such as water, steam, air, all our utilities. We've only had 3 such black plants in our 40-year history, and one of those was last fall. It gives us the opportunity to work on those common train equipment that we otherwise don't have the opportunity.
Well, I kind of a little trivia. I remember I was working at Dakota Gas in 2004 during the very first black plant. I remember long shifts, 6 or 7 12s, working nights. It was a real hootenanny, as they say. So how did it go from your end, this part? How did the people do? How did it hold up? And did you accomplish what you were hoping to?
Yeah, we did accomplish the major goals of the outage. The largest driver of the outage was to replace the boiler ductwork and dampener. This is what ties in all 3 boilers to the stack. And this can only be taken down during a black plant outage. We also did work on our cooling tower sump, which is common to the facility. And then we replaced several different valves, high pressure steam valves, some cooling water valves. All in, we completed over 4,400 work tasks and invested over $45 million into the outage.
That sounds like a very successful effort, and congratulations to you and all the folks for completing that. Especially as the calendar's turning, which leads me to the next topic. As much as I hate to say it, on this beautiful summer day, and I wrote this question last week, before the flooding, winter is just around the corner. Let's talk a little bit about how we get our generation and transmission assets and our subsidiary assets ready for these harsh conditions that we'll see in the next 6 or 10 months. Troy, you go first.
So due to the location of a lot of our facilities and the severe weather that we have in the wintertime, we've always had to prepare for the upcoming winters. And with that, the plant's usually around October, sometime in there, late September, October, we start going through checklists. And every winter, we have these pre-checklists to make sure that we're prepared. We check heaters, louvers, we do heat trace. They make sure that windows all seal up good, and then it's a reminder for employees that, hey, with the colder weather, make sure we're closing doors behind us. And we do that every time there's a storm coming. But operations and maintenance staff, they've been doing this long before it was required by NERC, and NERC really started focusing on it more after 2021 and Winter Storm Uri. And the bad things that came out of that winter storm had a lot of different things with marketing, plus we had a few deaths across the country, which that's not good for anything. So that's where making sure we have that reliable power comes in handy too. But during the regular season then, anything that comes up, we usually write work orders. Our operations and maintenance staff will take care of that. And then coming out of that, at the end, we get together, all the plant managers, and We kind of review the lessons learned, any of the major events that happen there. We talk through those and try and figure out how we can mitigate them to happen again in the future.
Thanks, Troy. Now, Val, I know you work closely with Troy and his teams during these winter weather events. Can you tell us a little bit about exactly what that means and how your team mitigates those adverse market exposures?
I sure can, Gavin. Our risk mitigation efforts really do begin long before the winter season or before any critical event may occur. Our team is continually monitoring forward power positions and forward gas positions and ensuring that we're not overly short or overly exposed to potential market prices during what we expect to be high impact timeframes. Those could be winter seasons, winter months. Those could be summer months when we typically see high load. And when we see high loads like that, we almost always have the ability for commodity price swings to take place. So we want to make sure that we have financial transactions in place or other short-term physical transactions in place prior to those commodity price swings coming into play so we can ensure that we're protected against those types of things. So once we do see weather that's indicating maybe a market tightness or a weather event, we do closely coordinate with Troy and his team. We have 2 people dedicated on staff to work with the plants, and they're communicating with them to make sure all of the generation that we have is as available as possible. Jeremy just mentioned availability is synonymous with reliability, so we want to make sure when we see these events coming that Basin Electric is as reliable as we can be. So we'll coordinate on unit startups and unit shutdowns to ensure that we don't have any unneeded cycling of the units where we introduce more risk by taking a unit offline maybe very early in the morning and then having to bring it back just a few hours later. We'll try to mitigate some of those time frames and coordinate on that. Another thing that our team does as we prepare for tight market timeframes is we have to ensure that we have fuel moving to our generators. And as our gas fleet is growing, there's more of a need for natural gas to reach our generators. So we have a lot of coordination that goes on there. And then finally, one of the other critical areas that we have to pay very close attention to during maybe a winter weather event or really tight market timeframes is our generation offers. We have almost 100 different generators or purchase power agreements that we are offering into the market on a daily basis. And we take the time every day to update those offers, but especially during market tightness or weather events, we pay very, very close attention to those offers to make sure we're not taking on any unneeded market risk.
Thanks, Val. So Jeremy, can you tell us a little bit about what you and your team do, either with your planning activities or procedures to make sure that we're ready for old man winter on the transmission side?
Yeah, I don't want old man winter. I like the golf season to carry on as long as I can. So, but yeah, I'll answer similar to what Troy was saying. On the front end, our engineers are currently working with our reliability coordinator, SPP, on seasonal assessments. So looking at fall right now, looking at winter, working with our transmission operator. So doing assessments, looking at what the load outages are going to be like in the future. One thing I found out about Gavin last week is that he doesn't like to be surprised. And we are similar on the transmission side, where we don't like to be surprised either. We're doing those assessments, looking for critical outages that the transmission operators are not surprised about tight system conditions. So we want to highlight those, and we appreciate working with the membership, what your load and what your outages are going to be during the season. Also, the TSM group does their seasonal winter patrols, looking at lines, checking out tank heaters, key substations. And then if we do have impending weather, we get into winter conditions, we have an upcoming storm, you know, we are making sure the staff is prepared, equipment's ready, fueled up, ready to go, and respond as needed.
Thanks, Jeremy, and thank all of you, in fact, for all your efforts during these winter situations that happen. I think most of us that are in the room today spend most of our lives in the northern plains in this part of the country where it can get viciously brutal during the winter. So I think the hard work that your teams do to keep our systems going, our plants running, our transmission system online through some of these deadly events in the winter, the efforts should not be understated. So thanks to all of you and your teams for that. I'd like to go back to Trinity now. Trinity, last year you told us a little bit about the CO2 sequestration project that was coming up. It was alluded to in some of the earlier discussions. Can you tell us a little more detail about that project? Was it completed? What's the status, and how are things going?
The new CO2 sequestration project has been going extremely well. We completed the project very close to original timeline, and it went into service on February 9th of this year. And thus far, we are far exceeding our budgeted expectations for sequestration. Additionally, it was a really smart investment to install 6 wells. We don't need 6 wells to sequester all of our CO2, but having that spare well capacity allows us to have a well down and do some work on it without impacting production. And we haven't had any production impacts due to the wells so far.
That's very good. And what specific activities have you done at the plant to make sure there's CO2 available to sequester?
Yeah, the CO2 comes from the gas path portion of the plant. So we need a reliable gas path and reliable CO2 compression and associated equipment. On the gas path side, we've been investing in compressor overhauls and replacement and upgrades of large vessels and equipment. On the CO2 compression side, the board has recently approved the first of 2 out of 3 compressor train upgrades, and that includes replacing the air-cooled heat exchangers. So think of them as giant radiators that help with interstage cooling on the compressors. We also are replacing our louvers, so flaps on the building that help with airflow, so it keeps it warmer in the winter, cooler in the summer. And then a water mist system, fogging system, that helps keep the train cool in the summer when it tends to be most limited.
That's good to hear, Trinity, especially with CO2 kind of becoming such a valuable commodity. And while CO2 might be the most recent co-product at the plant, it's by no means the only one. Can you tell us how the past year has gone for some of the more traditional co-products, such as ammonia and urea?
We've been having an outstanding year with our fertilizer products. In the ammonia plant, in April, we broke the all-time monthly and daily record. That daily record went back to 2001. And we didn't just break it once, we broke it 7 times. For the month, we averaged right around 1,180 tons per day. That's really saying something considering that the original design was 1,100 tons a day. On the urea plant, similar story. This time in June, we broke the all-time daily and monthly record. The monthly average that month was almost 1,200 ton a day, and likewise, the original design was 1,100. And when I say urea, it's equivalent urea, so urea plus diesel exhaust fluid. In June, we broke the diesel exhaust fluid record production, producing over 6 million gallons of diesel exhaust fluid. Year to date, the urea plant has been operating right around 92% capacity factor. And if you compare that to our best full year ever, that was in 2022, and that was 84%. So if things continue, we will far exceed that goal. And that didn't happen overnight. That happened through a lot of investment, control system upgrades, compressor upgrades, once again, large equipment vessel replacement. And you combine that with a well-trained and talented operations and maintenance staff that keep it running, and you've got our higher margin products that are really benefiting from these investments.
Sounds great, Trinity. The facility that you have up in Beulah is quite impressive. Like I said, I worked there for 7 years, and the people that you have are very committed to the work, and it's quite a technological success story. So I'd encourage anybody that hasn't seen Dakota Gasification, if you have the opportunity to take a tour, it's a pretty impressive place. So Aaron, I have not forgot about you. Todd alluded to some of the news coming from our friends in Washington and the EPA. Can you give us an update on the latest environmental regulations that your team has encountered during the last meeting?
Sure, Gavin. This is an updated version of the train wreck slide that we looked at last year. It generally lays out the rules that EPA has planned. And while not all of these rules directly impact Basin Electric or our facilities, it does give you a pretty good idea of EPA's agenda. There are also a couple of rules on here that don't currently impact us, but they could impact our ability to build future generation. Since the last annual meeting, EPA has been very busy. They have recently finalized several rules that individually would be a cause for concern, but collectively they really impact Basin Electric's ability to provide reliable generation. These rules include the legacy coal ash rule, an updated or revised mercury and air toxics rule, as well as a new greenhouse gas rule for new and existing units. And then in the last couple of months too, EPA has also proposed actions in both North Dakota and Wyoming on regional haze. To look a little closer at the recently finalized rules, the legacy coal ash rule focuses on ponds or impoundments at facilities that are no longer operating, but it also addresses any coal ash anywhere on plant site that's not part of a road or an embankment. The revised mercury and air toxics rule lowers the mercury emission limit for lignite facilities, and it also lowers the particulate matter emission limit for all coal plants. And then finally, the new greenhouse gas rule imposes carbon dioxide emission limits based on what EPA believes to be the best system of emission reduction.
The train wreck slide sure looks rather ominous. But hearing that and hearing what you just said about and seeing all the regulations that are coming down the road, two questions come to my mind. The first is, what do we need to do to comply with those rules? And the second is, how much would that cost?
Unfortunately, there isn't really a one-size-fits-all for compliance for all the units or even all the rules. It's really going to be a unit-by-unit and rule-by-rule compliance strategy. So for the legacy coal ash rule, we may need to remove material from facilities that have previously been closed under existing state programs. We also may need to remove coal ash on site, even if it was used for beneficial purposes. We're currently doing site assessments at all of the plants that will really drive exactly what needs to be done and then the costs associated with those actions. Our team in environmental has been working with engineering and operations and gearing up for the last few months for the mercury and air toxics rule. And so currently we are testing some additional mercury control options at both the Antelope Valley Station and the Leland Old Station. And we're also assessing our current particulate matter controls as well as what additional controls are out there. Depending upon what that analysis and assessment comes back at, compliance with that rule could range from $200,000 per unit to more than $100 million, depending on what additional controls are needed. And then as far as the greenhouse gas rule goes, Basin Electric has really put together a cross-functional team to look at the impacts to the coal plants and the associated costs. And under that rule, if a coal plant is willing to cease operations prior to 2032, they're actually exempt from the rule and don't need to do anything. So that's option one. If a coal plant is planning to operate in 2032 but is willing to close before 2039, then they would need to meet a carbon dioxide emission limit equivalent to co-firing 40% natural gas. So that's option two. And then if a unit was planning to operate in 2039 and longer, they would need to meet a carbon dioxide emission limit equivalent to 90% carbon capture. Our team is estimating that to comply with this rule, it will cost Basin Electric more than $14 billion in additional controls and replacement generation. There's also some implications to new generation in the greenhouse gas rule. It really limits what we can build in the future. So new baseload natural gas generation would also either need to install carbon capture technology or limited to a 40% capacity factor.
So $14 billion, if my math is right. That's almost double what we plan to spend in the next 10 years anyway. So it's pretty alarming. It's kind of a staggering number to think about. But is it a done deal? I mean, is this going to happen no matter what? What's our chances of getting out from under this?
It is absolutely not a done deal. While EPA has finalized the rules, the fight is far from over. All of the rules I've just discussed are currently being litigated. They're being challenged by Basin Electric, by NRECA, by state coalitions, other utilities, special interest groups. And while those challenges are ongoing, those parties have also asked for a stay or a pause in implementation of the rules while the cases work their way through the court system so that we don't need to begin expending that $14 billion.
Thanks, Aaron. It's alarming to say the least, and specifically if there's rules to put in place to limit how much we can run our gas generation, especially since Troy just mentioned a little bit ago that part of our issues are that we're running our gas fleet, we're running them so much, so we need the generation, we need to run them, and to limit them to 40% would be a large detriment. So getting back to why are we running these plants so much? Val, can you give some insight on why that's happening?
I sure can. So Basin Electric largely has natural gas generation in two areas, southeastern South Dakota and then northwestern North Dakota. And our gas generators up in the Bakken area are the gas generators where we do see higher capacity factors. A few things that are driving that. One, we have high levels of load in that area. And a couple other things, we are also seeing very low natural gas prices up in the Bakken market. Have been times over the last few months where we've seen sub 50-cent natural gas prices. So very low natural gas prices, which do incent the generators to run more. And then the third thing, we have seen congestion present in northwest North Dakota, which is driving up the market prices. So a combination of all three of those things are really increasing the capacity factors on the gas units up in northwest North Dakota. If you ever go to the spp.org website, and especially over the course of the last year, if you look at northwest North Dakota, oftentimes you'll see an orange or red color. And that's really the higher market prices and the congestion that are present in that area. Those prices are incenting units to be committed, dispatched, and then ultimately achieving the capacity factors. And those higher market prices or the congestion or the red on the map is also signaling that additional generation is needed in that area and could be potentially supported by prices that we're seeing that are driven by the factors that I mentioned earlier.
Okay, thanks, Val. We're talking a lot about reliability here, which, when I think about reliability, I typically lean toward it, talking about maintenance practices or run times or what have you, how we're physically operating something. But Aaron, can you speak to what helps or hinders reliability from an environmental compliance standpoint?
Sure, Gavin. One of the things that both Basin Electric and DGC do really well that helps to maintain reliability is to continue to operate our existing fleet in compliance with all permits and all of the current regulations. So our team in environmental works very closely with operations, with marketing, to ensure that with the goal that we're operating those units in compliance at all times. This really protects our existing resources and helps to maintain reliability. However, as we have previously discussed, the increased difficulty in building new facilities and the constant attack on the existing facilities really threatens reliability.
Well, thanks, Aaron. I appreciate your diligence. Right in Basin's mission statement, it says that we have a commitment to being an environmentally responsible co-op, and we certainly couldn't live up to that statement without your work and the work of your team. So thank you. Val, one thing that I've learned in this role for the past couple of years, and Erin just alluded to it when she's talking about working with operations, is that the communication and the coordination between the various divisions in our department are so important. Can you tell us how your team works with the generation team day in and day out when it comes to maximizing the availability of our units?
Yeah, exactly like you said, Gavin. Our team works with Troy's team and Aaron's team, Troy's team especially, on a daily basis. We have coordination. We have about 51 units that we are owning and operating and offering into the market. And on a daily basis, either our 24/7 real-time desk or our plant coordination team is working with someone from the facilities to ensure we have the most updated outages, D-rates, minimum uptimes, minimum downtimes, all of the physical parameters for the generators to ensure that we have those as updated as possible. We often also work to find solutions for problems that are occurring at the plant. We may have someone from the facilities call and say, hey, we're cycling a lot. this is causing problems in another area. Is there anything that we can try to do to mitigate this kind of cycling on the unit? And so often we will work together to try to find a solution. Many times we will come at it from a different approach, or we'll have a different idea as to how to get things done. But at the end of the day, we both have the goal of ensuring the units are as available and reliable as possible. Over the last year, as I thought about it, we've worked on a few different solutions where I was really proud of our team and the facilities team and the way that the two areas came together to find solutions for reducing the cycling at Leland Knolls and Laramie River Station. We worked with the Deer Creek Station to optimize unneeded startups. And then our team worked with the environmental team to ensure we maintained compliance on our facility. At the same time, ensuring we had enough hours available to run during very peak market timeframes. So the teams do work very well together.
Thank you. Now, speaking of natural gas prices, I'm remembering back to some of your board slides, and you show the prices, for the past few years, looking out into the future, and it's just like that. It's very volatile. So how does your team manage the constant movement in gas prices?
You're right. We have seen very volatile gas prices, and we're currently in a time frame of low natural gas prices. I mentioned the 50-cent prices in the Bakken earlier. We've seen prices around $2 in the Ventura market area for the majority of the year. But we all know that we can't guarantee low natural gas prices forever. So our team does work very hard to mitigate our exposure for future natural gas prices. Our first layer of protection for forward natural gas prices is through DGC gas sales. The index where we sell DGC gas is the same index where we purchase gas for the Basin Electric generators. So that's really our first layer of defense against future volatile natural gas prices. However, as our gas fleet continues to grow, we've seen a shift where our gas units at Basin are burning more than the natural gas that we produce and sell at DGC. So by 2026, our projections reflect that Basin Electric will burn twice as much as what we sell at DGC. And by 2030, Basin Electric will be burning 4 times as much natural gas as we sell at DGC. So this chart really shows a pretty dramatic change in the comparison of DGC sales and Basin Electric burns. So given this shift, we manage the exposure with longer physical natural gas purchases and longer financial execution of natural gas swaps, which help to ensure that we fix our future financial exposure to gas prices.
Thanks, Val. Jeremy, I haven't forgotten about you over there. It was mentioned a little bit earlier this morning about our aging infrastructure initiative that began in 2018 to strengthen and modernize our infrastructure. I like to say that Basin Electric was talking aging infrastructure before aging infrastructure was cool. So Jeremy, can you give us an update on that program and where things are at?
Yeah, so as Chris mentioned earlier, we started this initiative back in 2018. A lot of our transmission facilities were built back in the 70s and 80s. And even though I don't think that's that old, that's kind of the end of the useful life for some of these circuit breakers and electrical mechanical relays. And so we've taken a systematic approach to look at the various substations and equipment and replace those as they've preemptively replaced them before they fail. It's easier for us to take them out of service and replace them on a planned basis than to have them fail. We have kind of a snapshot of our current timeline. See a lot of these projects started back in 2018, 2019. We had a slowdown due to COVID, and then kind of picked back up after we kind of came back to the office. The blue represents projects that have completed. Green represents projects that are approved and underway. We've taken kind of a pause here to start any new ones because we just got so much going on. I think it's better to kind of wrap some of those major projects up. And in addition to that, we're under one of the most large, intensive transmission build-out that's currently underway.
Well, why don't you tell us a little bit more about that?
Yeah, so I won't try to hijack Matt. I know is going to talk about some of the transmission build-out at our current projects in the next panel, but we are seeing for the load growth in generation interconnection just a dire need for additional transmission, and this is not just in our area, but in the SPP's area, but MISO area, just a large need for additional transmission, and that's critical to the reliability of the system because it allows that economic transfer of power from the generation stations out to the load. So just a big, more transmission coming.
Okay, thank you. And you'll be taking pictures of it someday, right?
Absolutely.
Okay. There's a panel following this one on investment, so I won't steal too much of their thunder, but I will ask Trinity, since you aren't on that panel and you're on this one, can you tell us a little bit more about how DGC has invested in one of the most precious resources of all, its people?
Yeah, the training and safety of our people is essential to our success. And one of those groups that helps keep us safe is our fire and rescue team. That team comprises of our protection services group, our shift maintenance, and other volunteers throughout the plant. And this is the group that 24/7 responds to fires, spills, medical emergencies, and any type of rescue. And that last one, rescue, there's a certain type of rescue called a rope rescue that requires specialized training and specialized equipment. And historically, we only did 8 hours of internal training on this, and we decided this year that we really needed to do better. We had to step that up. And so we partnered with the North Dakota Safety Council. We hired a third-party rope rescue training expert to administer the training. And we took all 4 of our fire rescue crews and sent them off-site for 40 hours of training. This hands-on training with the specialized equipment was fantastic. And one of our protection services supervisors, Brian Heiner, stated that it was among the best training he's received in his time at DGC.
Well, thanks, Trinity. That's so important. I think, like I mentioned, when I think about reliability, I first turn to steel in the ground. When it's also relevant to processes and relevant to our human capital and our training that we give to our teammates across our service territory. We've made great strides in the past several years in the training aspect, the safety efforts, and all of that leads to greater reliability. The last question I have, I'll give you a little background. As we were preparing for this question, we were talking, amongst the panelists, and we're kind of kicking things around. And this last question that I had, nobody liked it but me. We took a vote, and it was 5-1 whether I should do this question, because like I said, there's 1,500 people that work on reliability every day. And they work through some of the harshest conditions, some of the longest hours that you can imagine. And a lot of your teams do the same thing out on the distribution level. So you know what it's all about. So it's impossible to single out one person, and on jobs like this. But I decided eventually that I'm the guy with the microphone, and I ask the questions. So I realized that nothing happens in a vacuum, and every positive outcome is a result of a large group of people and a lot of team efforts. So I recognize that, and I don't mean to leave anybody out, because everybody's working very, very hard for the reliability of your assets. But we're going to do it anyway. So in 1 minute or less, we're going to go around the table, and I want you to tell me about an instance in the past year when one person from your team went above and beyond in the name of reliability. So Jeremy, we'll start with you.
Yeah, so this was tough because our TSM teams work together in crews, and like you said, no project is done by one person. But the person I picked for this goes down Phil Westby. He worked on a couple projects that Todd mentioned in his remarks. The Judson RAS, or the Williston Remedial Action Scheme that was implemented. Phil led that effort through the SPP process, all the study work and getting that implemented. And he was also intimately involved on the dynamic line rating project, on the getting that project up and going and coordinating with WAPA and SPP. So appreciate his efforts and all that, and for the reliability up in the Bakken area.
Thank you. Val?
Yes, Gavin, when you asked this question, there was someone that came to my mind, and I thought back to January when we had a very cold spell winter weather event, and that usually requires a lot of time and attention from our team. And the person that I thought about was one of our gas traders, Ali Evanenko. And Ali manned the gas purchasing for that event, day, night, weekend, and ensured that we had fuel flowing to our natural gas generators for days on end. It's a difficult process because on the supply side, natural gas can be harder to come by during these events. It's very expensive. It creates a lot of stress to have to make those types of purchases. And then once you have it purchased, the gas doesn't always flow. So that's very challenging. On the demand side, the market can dispatch a gas generator with a short notice, and you need to have the fuel there to ensure that it can run. So it's a very challenging time frame to work through. I'm very proud of Ali and her efforts during that event, and very proud of her and the gas team for the work that they do every day to make sure our generators are reliable.
Thanks, Val. Trinity, your turn.
Yeah, I had to mention Claude O'Berry. Claude retired just this past month after 40 years of service at DGC. Claude was there for the very first flow of natural gas down the pipe, and he made sure to wait to retire until he saw the 40th year of natural gas flow down that pipe. Most recently, Claude was our operations superintendent for the protection services and the pipeline group, and Claude was relentless about making sure we maintain reliability and integrity of our 200-mile CO2 pipeline up into Canada. He also led a part of the team that was responsible for the startup, the successful startup of our CO2 sequestration pipeline.
Thank you, Trinity. Troy?
Yeah, and again, this is very tough. I got a large group, and it's very hard to pick just one because all the generation team members, they all care about their units and they want to make sure they're reliable. But one of the most recent ones was Tyler Mickelson. He is the plant engineer at Antelope Valley Station, Leland Old Station. He's been with Basin for about 19 years. But at ABS, we have 4 boiler circ water pumps in each unit. And when one of those would fail, we would have to take an outage. One was always kind of an in-service spare, but we would have to take an outage, send it off for repairs, take another outage, and then have it reinstalled because we didn't have a spare in the warehouse. Tyler was one of the first ones to suggest getting a spare for the warehouse. That way we can have just a one outage, remove that pump, put the other one in place, and we do it during an opportunity outage. That's when prices are down. A lot of renewables or something where we don't necessarily need the power that day, and then we can take that opportunity outage. But Tyler worked with our electrical and planning departments to make that happen.
Thanks, Troy. Appreciate that. Aaron, bring us home.
Yeah, I also really struggled to choose one individual, so thanks, Gavin. As I mentioned before, compliance with existing regulations is a very important part of maintaining reliability. And for the past several years, our team in environmental, along with Laramie River Station staff and engineering and lots of other folks from Basin Electric, have been working to bring the Laramie River Station ponds into compliance with the last batch of coal ash rules. And as we're getting down to the end and limited compliance time and limited space, the team came up with a preferred option, and it really fell to Mark Deely on our team to communicate that adequately to the Wyoming Department of Environmental Quality, to lean on those relationships and to get their buy-in and ultimately complete the permitting so that we could move forward with the project. So I'm just very appreciative to Mark and to everyone who worked on that project.
Thanks, Aaron, and thanks to all of you for indulging me in that question. But I did it on purpose, and the reason that I wanted to do that was we talk about reliability, and most of the time we think about reliability as a number, and we get a number across the board or across the printout or whatever, across the email, and we smile if it's a good number and we frown if it's not. But I really wanted to put a face to what reliability is. And I think if you asked those 5 people that we just highlighted what they thought of being highlighted in this manner, they probably wouldn't like it. They'd probably say, they'd probably say something like, I was just doing my job, or it wasn't just me, it was the whole team. and that is a very valid response on their part. But I did want to just take some time to highlight one person. If we did this again next year, I can guarantee you that it won't take very long for these folks to find 5 new faces for you of reliability. So that kind of brings us to the end of the panel. I want to thank all of you for being on the panel today. It's my pleasure, again, that I get to work with you, all of you, on a daily basis. I'm very proud of the work that all of you do, and I'm very happy and proud to be able to share it with the fine folks that are here today. We don't have a scheduled Q&A session with the timing that we have today, but I can tell you that everybody here will be here tonight, they'll be here the rest of the afternoon, and they'll be here tomorrow. So if you think of something that piqued your interest, or something you want to learn a little more about, please don't hesitate. Grab any of us and ask any questions that you have. And with that would be the end of our panel. I want to thank you all for your attention. I want to wish you a well in the rest of the meeting, and stay dry. Thank you.